date time module. So there is a date and time. So, and one more module you have, and that module is calendar module. We have seen date time module, and also we have seen calendar module. So after this date time and calendar module, so let us talk about, so that is, so multi-threading. So there is a multi-threading, right? Multi-threading or multi-processing. So there is a multi-threading or multi-processing, right? So let us see how to work with this multi-threading or multi-processing applications. So how to work with this multi-threading? So multi-threading or multi-processing here. So, so what is a multi-threading or multi-processing here? Okay. So actually, so the applications are two types. You find two types of applications. So one is called as single tasking applications. One is called as single tasking applications, and one more is called as multitasking applications. So applications are two types. So one is called as a single, and second one is called as multitasking applications. So there are two types of applications. One is single tasking, and second one is what? Multitasking. Okay. So here, what is a task? Okay, task is nothing but task is an operation. Task is an operation performed by. Task is an operation performed by a application, or what is that here? Program. What is the meaning of task here? A task is nothing but an operation performed by an application or program is called as which one? Task. So what is this single tasking application is? An application which allows to perform, okay, an application which allows performing, okay, which allows performing one task or one operation at a time is called which application? Single task application. An application which allows performing one task, which allows performing one task or one operation at a time is called which application here? single task application. For example, if you are working with certain applications, for example, if you see old mobiles, okay, suppose you open contacts. If you open contacts, until unless you don't close the contacts, you cannot open what? Any other application. Suppose if you open some media player, until you don't close the media player, you cannot open what? Any other application. It means it allows you to execute how many operations? Only one operation. So such kind of applications is called as which one? Single task application. But when it comes to the multitasking applications, when it comes to the multitasking applications, multitasking application, an application, an application which allows performing more than one task, more than one task, more than one task or operation how? Simultaneously. More than one task how? Simultaneously. Simultaneously or what? Concurrently. Simultaneous is called which application here? Multitasking application. Because one processor can do how many operations? Only one operation. But simultaneously it can able to do how many operations? More than one operation. But one processor at a time, it can do how many operations? Only one operation. But simultaneously it can able to do how many operations? More than one operation. An application which allows performing more than one task or operation simultaneously or concurrently is called multitasking applications. And these multitasking applications, these multitasking applications are two types. One is called as a process-based multitasking, and second one is called as thread-based multitasking. Okay, so these applications are how many types here? Two types. These multitasking applications are how many types? Two types. One is called as process-based multitasking, and second one is called what? Thread-based multitasking. But what is the need of multitasking applications? Utilizing the CPU idle time. For example, one student at a time he can do how many courses? Only one course. At a time he can do only one course, but simultaneously can do more than one course. What student is doing? Utilizing his idle time to do what? Another course. It means within the same time, how many courses you are doing? More than one course. In the same way, for example, I open Notepad. I open which one? Notepad. I'm not doing anything on Notepad. It means your CPU is idle or not? Yes. Now I want to utilize that idle time to execute which one? Another application. Then immediately I'll open which one? Paintbrush. So I'm not doing anything on Paintbrush. It means CPU is what again? Idle. Then I can utilize that time to execute what? Another operation. Getting on. See, every program requires an input as well as what? Output. For example, I click on download. When I click on download, it should connect it to what? Server. It should get the data and it should save the data in your system. It means meanwhile your CPU is what here? Idle. It's not doing anything, right? So I want to utilize that idle time to execute what? Another operation. Then I'll use which applications here? Multitasking applications. Multitasking applications are how many types here? Two types. One is process-based multitasking and one more is what? Thread-based multitasking. Process-based multitasking, it is suitable for developing operating systems. process-based multitasking. Process-based multitasking. So process-based multitasking is used to develop which one? Operating systems. It is useful at which level? Operating system level. What is a process? What is process? A process is a program. A process is a program under execution. Process is a program under what? Execution. Or you'll say a process is an instance. A process is an instance of which one? Program. So whenever you execute a program, your operating system will create one process. Whenever you execute the program, your operating system create one process, and within that process, it will load your program and execute all the instructions. So when it comes to the process-based multitasking, is nothing but process-based multitasking is nothing but simultaneous execution of simultaneous execution of more than one program. Simultaneous execution of more than one program or application. Simultaneous execution of more than one program or application is called what? Process-based multitasking. Is called process-based multitasking. And process-based multitasking is used to develop which one here? It is suitable to develop which applications? Operating systems. For example, if you take what? Windows is what? Multitasking operating system. But which multitasking operating system? Process based. Now Unix is there. It is also multitasking operating system. Linux is there. Linux is also multitasking operating system, right? So simultaneous execution of more than one program or application is called process-based multitasking, and process-based multitasking is used to develop which one here? Operating systems. Getting on, or just try to understand this. For example, yes. For example, yes. For example, assume that this is you have an operating system. What is this operating system here? Windows operating system. So what will happen in Windows operating system? Okay, so this operating system is a multitasking or not? Yes. What will I do? Assume that I will open first. Assume that I will open first a notepad. What I'm doing first, I'm trying to open which one? Notepad. I open notepad. So your operating system will create one process. Means it allocates some time, it allocates some space. Okay, it will create a process. And instead this which program? Notepad program. Suppose I'm not doing anything on notepad. I'm not doing anything. It means your CPU is idle or not? Yes. If I want to open WordPad, or if I want to open WordPad or any other editor, will you close the notepad? No, not required, right? So when the notepad is in running, running, can I open another program or not? Yes. When notepad is in running, can I open another program or not? Yes. It means your operating system is able to execute how many programs? More than one program. But at a time, you can work on only one program. You cannot work on notepad and paintbrush. No. Either you activate notepad, you either activate which one? Paintbrush. But at a time, you cannot work on both, right? You switch from one program to what? another program. So there will be a context switching between one program and what? Another program. But at a time, you cannot work on two programs. No. Simultaneously, you can work on what? Two programs. But at a time, you can do only what? One. Because one processor can do how many operations? Only one. But simultaneously can do how many operations? More than one. So that scheduling is done by operating system. So when notepad is in open, I don't require to close the notepad to open which one? Paintbrush. I don't require to close the notepad to open which one? Paintbrush. I just open another process. So what is this process? This is called as which one? Paintbrush. So when the paint is open, then I can open another program. So what program I can open here? MS Word. Okay. So for opening MS Word, is it required to close Notepad and Paintbrush? No. So I can open MS Word. When one program is running, can I open another program or not? Yes. I don't require to close one program to open what? Another program. You can see here you have a task manager, right? See, just open task manager here. So in task manager, can you see the process? So here, how many processes are running? So how many processes are running or not? Yes, you can see what is the process here? Word. What is open? Windows Explorer is open, Paint is open, Zoom meeting is open. A lot of things are open or not? Yes. It means your CPU is scheduling it. Okay, now you can see Microsoft Word 0%, Paint is 0%. Okay, Task Manager. Now which one is currently running here? Two programs are simultaneously running or not? Yes, one is a Zoom meeting and one more is what? Task. But is it remaining programs are using or not using? Not using. It means CPU is what here? Idle. Getting on. It means you can now the scheduling of these programs are done by which one? Operating system. So it will switch from one program toward another program. But this process based multitasking is suitable at which level? Operating system level, but not at which level? Application level. It is suitable at operating system level, but not at which level? Application level. But I want my program should execute simultaneously more than one operation. For example, I write one program. Suppose I write one program here. Okay, assume that I'm just writing one program and I want my program should perform more than one operation simultaneously or concurrently. I want more than, no, I want my program should perform more than one operation simultaneously or what? Concurrently. Then how my program can perform more than one operation simultaneously or what? Concurrently. Okay. Yes, just here. For example, see here. So by default, whatever program you write it. For example, I write a program with some function one. So there is a function one. Now I'll just write here inside what is that? Function one. And there is another function called function two. So here I'm saying inside what is that? Function two. And there is another function called function three. So inside what is it again? Function three. Okay, so how many functions are there in my program? Three functions are there. There is a function. What is a function here? Main. And this main is calling the function one and then calling function two and calling which one? Function three. Okay, now my program is doing how many operations? Three operations. Now my program execution starts from where? My program execution starts from which function? Main. So how many executable statements are there? One. And what is this executable statement? Main. So my program execution starts from where? Main. So which function is called first here? Main. And then main is calling which function? Function 1. So until execution of function 1 is not completed, will it execute function 2? No. Because this function 2 is depends on which one? Function 1. Function 2 execution depends on what? Function 1. Execution of function 1 is completed. Yes. Once the execution of function 1 is completed, it will return to which function? Main. It will return to which function? Main. Okay. Then is it execution of function 1 is completed? Yes. Then go to the next statement. What is the next statement here? Function 2. Then the control is moved from main function to which function? Function 2. Now, until execution of function 2 is not completed, will it execute function 3? No. If it not execute function 3, now once the function 2 execution is completed, it will return to what again? Main. Is it execution of function 2 is completed or not? Yes. Then it will call which one here? Function 3. So function 3 is called. So function 3, it will display the message inside function 3. Is it execution of function 3 is completed? Yes. Then return to which one? Main. Now, your program execution by default is sequential or not? Yes. Is it sequential or not? Yes. First it execute what? Function 1. Then execute function 1. Then execute function 2. Then execute what? Function 3. Is it all these functions are executed how? Sequentially, one by one. It means until execution of one, it means is it this application is a single tasking or multitasking? Tell me, is it this program is single tasking or multitasking? Single tasking. It means your program is doing how many operations? Only one. Until function 1 is not completed, it will not call which one? Function 2. Until function 2 is not completed, it will not call which one? Function 3. It means each operation, one operation depends on what here? Another operation. One operation depends on what? Another operation. Until one operation is not completed, it will not execute what? Another operation. But I want all these operations to be executed individually. I want all these operations to be executed what? Individually or independently. I don't want one operation should be depends on what? Another operation. I don't want one operation should depends on what? Another operation. Then you put this operation in a separate execution path. You put this operation in a separate execution path, and that separate execution path is called as which one here? Thread. That separate execution path is called as which one? Thread. So why you are writing a thread? You are writing a thread to perform operation. Why you are writing a thread? To perform operation independent of. I want this operation to be executed independent of what? Other operations. I want this operation should be executed independent of other operations. Suppose function 1 depends, function 2 depends on what? Function 1. Function 3 depends on what? Function 2. But I don't want one function should depends on what? Another. I want all these functions to be executed separately. Okay, I want all these functions to be executed how? Separately or independently. Then you write this operation in independent part, and that independent part is called as which one? Thread. And threads get executed how? Simultaneously. Simultaneously. You can execute this threads how? Simultaneously. And execution of this more than one thread simultaneously is called as which application? Multi-threaded application. Multi-threaded application. So by default, your program execution flow is what? Sequential. So what is this thread-based multitasking? So thread-based multitasking is suitable at which level here? Application level. Now you use in application development, you'll try to use which one? Threads. Okay, so thread based multitasking. Thread based multitasking. Thread based multitasking. So what is a thread here? So what is thread? A thread is a thread is an independent a thread is an independent part of a thread is an independent part of execution within program. So thread perform operation independent of which operations? Other operation. A thread is an instance. A thread is an instance of which one? Process. Process means program. And your program is divided into a number of threads. Your program is divided into a number of sub-processes, and each sub-process you call it as what? Thread. So thread is an instance of process. A thread is a process under execution. Thread is a process under what here? Execution. Thread is a process under execution, or thread is a child. Thread is what here? Child process. Thread is a process under execution, or thread is called child process. So simultaneous okay, so simultaneous execution of more than one thread is called which one here? Multi is called as which one? Multi-threading. Simultaneous execution of more than one thread is called as which one? Multi-threading. For example, I'm developing one application. So this is my application, and this application is having two things out there. One is download, and one more is which one? Upload. So how many buttons are there here? Two buttons. So one button is called as which one here? Download. So one button is called as download, and one button is called as which one? Upload. Suppose if I click on download, then it will do which operation? Download operation. If I click on download, then it do which operation? It will do which operation? Download operation. If I click on which one here? Upload, it will execute which function? Upload function. If I click on download, it will execute download function. If I click on upload, it execute what? Upload function. Suppose I click on download, it will call which function? Download function. Until download function execution is not completed, I cannot click on which one? Upload. I cannot click on which one? Upload. Suppose I want this download and upload, this both the functions to be done how? Simultaneously. Then you write these operations inside one upload thread. One thread depends on another thread? No. Threads will be executed what? Individually, independently, or what? Individual. So one thread doesn't depends on what? Another thread. If I click on download, so which thread start executing? Download. While downloading is in running, you can just click on which one? Upload. Which thread will be running now? Upload. So parallelly, it will run how many threads here? Two threads. Thread. Yes. So thread is an independent part of thread is an independent part of execution within the program. Okay. Yes. So simultaneous execution of more than one program is called as multi-threading. So what is the advantage? Advantage of developing multitasking. Okay, advantage of developing multitasking applications. Multitasking applications are okay utilizing what do you call it as CPU, which time here idle time. Advantage of developing multitasking applications. Advantage of developing multitasking application is utilizing CPU idle time, right? Python, in Python, we can develop, okay, multi, multitasking applications, multitasking applications. In Python, we can develop multitasking applications. In Python, we can develop multitasking applications using which module? Threading module. So Python is provided one module, and what is the name of that module here? Threading module. Threading module is there. What is the name of that module? Threading module. And this threading module is a default module. Threading module is default module which comes with software, Python software. Threading module is a default module which comes with the Python software. So you don't require to install the threading module. It comes with which software? Python software, right? As a default module which comes with the Python software. Okay, right? Yes. Now here, thread scheduling. So how the threads are scheduled? See, as it concurrently it execute the threads. Now, who will execute general instructions? The instructions are executed by whom? Processor. Instructions are executed by whom? Processor. And who will schedule the execution of instructions? Operating system. Operating system. Functions of operating system is what? Memory management, IO management, process management, device management. All these are functions of which one? Operating system. Who will allocate the time of the CPU for the instructions? By the operating system. Scheduling of the instructions or programs are done by which one? Operating system. Who will allocate the time for every process? By the operating system. So operating system is having what? Scheduler. Operating system is having what? Scheduler. There are different types of scheduling algorithms you find. One is called as time slicing, which you call it as like preemptive scheduling, and one more is what? Non-preemptive scheduling. Like one is called as a time slicing, and one more is what? Priority based. Okay, so there are different types of scheduling algorithms implemented in what? Operating system. But most of the operating system uses what? Time slicing. It means for every process or a thread is given some predefined time. It is given some predefined time, and within that predefined time, it execute the instructions. And after executing the instructions, again it is scheduled for what? Execution. Suppose there is one task. There is one task is given some 1 millisecond. It will execute within 1 minute. Again, it is scheduled for what? Execution. So here, execution of threads are scheduled by, okay, scheduled by which one? Operating system. Actually, I should say scheduled by which one? PVM, that is Python virtual machine. Because who execute the Python program? PVM, that is Python virtual machine. But this Python virtual machine will work on the top of which one? Operating system. So whatever scheduler algorithm used by operating system, the same scheduling algorithm used by Python virtual machine. Whatever scheduling algorithm used by operating system, the same scheduling algorithm used by Python virtual machine. Just try to understand. Execution, there are different, different scheduling algorithms, algorithms used by which one? Operating system. Like I said, like time slicing, which you call it as preemptive scheduling, and one more is what? Non-preemptive scheduling. Okay, preemptive scheduling, and one more is non-preemptive. Preemptive comes like time slicing. Non-preemptive is like which one? Which you call it as which one here? Priority base. Priority base might becomes in what? Non-preemptive scheduling. Different algorithms used by Python virtual machine for scheduling of which one? Threads. Okay, right. Then next is how to create a thread. Okay, how to create a thread. Why you are creating a thread? Why you are creating a thread? You create a thread to perform operation. Why you are creating a thread? To perform operation independent of other operations. Why you are creating a thread? You are creating a thread to perform operation only. Why you are creating a thread? You are creating a thread to perform operation independent of what? Other operations. Independent of other operations, you are creating what here? Thread. Okay, now, right. So how to create a thread? Now, we can create a thread in two ways. We can create a thread in two ways. Okay, first one is like using some callable object, and second one is by using callable object, and second one is by inheriting which class? Thread class. How many ways can you create the threads here? Two ways. One is using callable object, and second one is by inheriting which one? Thread class. By inheriting thread class. Okay, two approaches are there. Two approaches are there for creating which one? Thread. But who will schedule the execution of thread? Scheduling of execution of thread is done by which one? PVM, which is called as a Python virtual machine. So this Python virtual machine is having a scheduler, and that scheduler works on the top of which one? Operating system. There are different types of schedulings you find. One is time slicing, and one more is what? Priority base. One is a time slicing, and one more is a priority based, right? So we can create a thread in two ways, using callable object, and second one is by inheriting which class? Thread class. So first we'll see creating a thread using callable object. Creating a thread using creating thread using callable object. So how can you create a thread using which one? Callable object. Creating a thread using callable object. So what will happen in this case? In this approach is, in this approach we create a thread object. We create a thread object using which class? Thread class. We create a thread object using thread class. While creating thread object, while creating thread object, we define, while creating thread object, we define, target. While creating thread object, we define target as a function. We define a target as what here? Function. So what is a target is? A target is a function which has to be executed by which one? Thread. A target is a function. See here, target is a function. Target is a function. Target is a function which is executed by what? Thread. It means the operation performed by a thread is defined as a target. Operation performed by thread is defined as what here? Target. Target. Operation performed by thread is defined as what here? Target. So which operation the thread has to be performed, that you are defining it as what? Target. So creating a thread using which object here? Callable. Approach, what you do is you create a thread object using which class? Thread class. But while creating a thread object, we define the target as what? Function. What is this function defined here? The operation performed by which one? Thread. For example, see here. For example, suppose, okay, for example, so this is one program where you have two functions. One is a even function. So what is the name of this function here? Even. Now even is a function which is able to generate which numbers here? Even numbers for n in a range of, okay, 1 comma 21. Now this function will generate, this function I'm using to generate the even numbers from 1 to 20. So here I'm checking one condition. If n mod 2 double equal to what? 0, then I'm just printing this is which number? Even number. So even, and then I print the value of what? N. So this function is used for generating which numbers? Even numbers. This function is used for generating which numbers here? Even numbers. You are generating it by using a function called which one? Even. You are generating this by using a function called which one? Even. Even is a function, right? Then I try to write one more function which is called as order. Now this function is used for generating which numbers? Odd numbers, where I'm saying a range of 1 comma 21. If n mod 2 is not equal to what? 0. If the number is this, then I'm trying to print this number is which number? Odd number. So there is a even number and there is which number? Odd number. So how many functions are there here? Two functions. One is a function called even, and one more is a function called which one? Odd. So one is generating even numbers, the other one is generating which numbers? Odd numbers. Then next is, I want these two functions to be executed simultaneously. Suppose what will happen if I say even? I call even function and I call which one? Odd function. So what will happen in this case? Will it this both the functions will be executed simultaneously or one by one? One by one. So first it will call which function? Even function. After execution of even function, it will call which function? Odd. Means until even number generation is not completed, it will not do which operation? Odd. So it means, is it single tasking or multitasking? Single tasking. This is not multitasking, right? Now this is what here? Single tasking, because it will try to perform, or it will try to execute first even numbers, and then it will generate which numbers? Odd numbers. Okay. So once you run this, so first it is generated even numbers, and then generated which numbers? Odd numbers. But I want these two generations to be done simultaneously or what? Concurrently. Then what will I do? I'll put these two functions inside what? Thread. I'll put these two functions inside a thread. So to create a thread, I should import one module here. So what module I have to import? Threading module. So I imported threading module. In threading module, you have a thread class. Now T1 equal to threading dot. What object you are creating? Thread object. You are creating object of which class? Thread class. And this thread object should perform. This thread object should perform some operation or not? Yes. Whatever operation is performing, that operation you define, it has which one? Target. So what is the target for this particular thread here? Even. What is the target for this particular thread is here? Even. It means this thread will generate which numbers? Even numbers. This thread will generate which numbers here? Even numbers. Because what is the target for this particular thread? Even. Okay, then T2. T2 equal to what is it? Threading dot. Threading dot, what is it? Thread. This thread should execute. This thread should perform which operation? Odd number. So what is the target for this particular thread here? Odd. Now this is without inheriting it. You're directly creating which object? Thread object. You're directly creating which object? Thread object by defining which one here? Target. So for this thread 1, the target is the even number. For this thread 2 is the target is what? Odd numbers. By just creating a thread, will it be a thread is executed? No. So who will schedule the execution of thread? PVM, our operating system. Then how can I execute a thread? How can I execute a thread? How can I schedule the execution of thread? By calling one method called which one? Start. By calling one method called which one? Start. How can you execute a thread? You can execute a thread or you can schedule the thread for execution by invoking which method? Start method. You can execute the thread or you can schedule the execution of a thread by calling which method here? Start method. So where I write here T1 dot start and I'm writing here T2 dot what is that? Start. You are trying to invoke the start method of thread 1. You are invoking the start method of which one? Thread 2. Now try to execute this in the command prompt so that you can see the output properly. So just try to execute in the command prompt. But in ideally also it execute, but you don't get the output properly. Because of that, I'm trying to execute in what? Command prompt. So open the command prompt and open the folder where your program is there. So your program is there in Python. Okay, now this is a folder, right? Just open and then say Python. What is my program? Some test1.py. Test1.py. Now you can see, if you see this output, right? First it is generated how many even numbers? 1, 2, 3, 4, 5, 6. It means the scheduler given some time. Within the time, this event thread is generated how many numbers? 6 numbers. And after that, it is switched to which one? Odd. And within the odd, it is generated how many numbers? 1. Within the given time, it is generated only 1. Because execution of thread is completely depends on what? Scheduler. Getting on it. Execution of a thread is completely depends on what? Scheduler. Scheduler only. Suppose event thread is given some time and within that time it is generated how many numbers? 6 numbers. And then it is scheduled which one here? Odd thread. But within that time it is generated how many numbers? Only 1. And then switch to which thread? Even thread. And then switch to which thread? Odd thread. Then generate which one? Even. Odd, even, odd, even. Is it execution of even thread is completed? Yes. Then executed which thread here? Odd thread. But is it this output will be the same always? No. If you execute again, you may get some other output because scheduling is done by which one? Operating system. Now it is executed, even thread is generated how many numbers here? Two numbers. It must given a time, within a given time, it is execute or it is generated how many numbers here? Two numbers. And after generating two numbers, it is switched to what? Odd number, and then switch to which one? Even number. Now, is it execution is simultaneous or not? Yes. Simultaneous. Now you can execute the you can schedule the execution of a thread by calling which method here? Start method. Until you don't say start, is the thread execution is done or not done? Not done. Not done, right? But is it one by one or simultaneously? Simultaneously. That is what? Simultaneous execution of more than one thread. Simultaneous execution of more than one thread is called as what? Multi-threading. Simultaneous execution of more than one thread is called as multi-threading. Multi-threading. Okay, that is the definition, right? So try to execute in the command prompt. So here there is a method called which one? Start. So there is a start is there. So start is a method of a thread class. Okay. Is here. Start the thread activity. Okay, so there is a method called start. So start is an instance method of thread class. Start is an instance method of which class here? Thread class. But what start is doing? Start the thread activity. So by just creating a thread object, thread is not executed. If you want to execute a thread, you must call which method? Until unless you don't call the start method, your thread execution is not done. So it is always you have to call the start method. Now this is creating a thread. This is creating a thread. So this is creating a thread. Yeah, this is creating a thread using which object? Callable object. But you can also create a thread. You can also create a thread. Okay, now this is a second approach. The second approach is creating thread by inheriting. So creating thread by inheriting which class? Thread class. But what is the advantage and disadvantage? Like suppose if you are creating a thread using callable object, what is the advantage of creating a thread using callable object is whenever there is a changes in the functionality of a thread, I don't require to do any changes in what thread, but I just do the changes inside what function. But if you are talking about inheritance, right? Whenever there is a changes in thread, I have to do changes in which class? Thread class. So maintaining your application becomes what? Complex. So that's the reason you most of the times you'll go for which one? Callable object, but rather than what? Inheriting a thread class. So a thread can be developed. A thread can be developed by inheriting. A thread can be developed by inheriting which class? Thread class. So inheritance type of. Okay. A thread can be developed by inheriting thread class. So the class which inherit thread class must override the class which inherit all the properties of which one? Thread. So your class will be an instance method. One instance method called which one? Run. You have to override one instance method. What is that instance method here? Run. You have to override this run method. So this run method contain the operation performed by what? Thread. So the operation performed by a thread, you'll write inside which method? A run method. It means whenever thread is executed, a thread is executed by calling which method? A run method. Whenever thread is executed, it is invoked or executed. It is invoked or executed by calling which method? Run method. Okay. So whatever operation you are doing it, you need to write that operation inside which method? Run method. So what is the syntax of this? Okay, you are developing a thread by inheriting which class? Thread class. You are writing like this class. Class what here? Class name or thread class name? Class name or thread class name. Now this will inherit which class here? Thread class. Threading dot thread. So class thread class name and this thread class inherit which class here? Thread class. Threading dot thread. Now here threading is a module. Here threading is a module and thread is what here? Class. After writing a thread class, you write operation of a thread inside which method? Method. So this is called as which method? Overriding. This is called as which method? Overriding method. Whatever logic means, whatever operation your thread want to do, that operation you write inside which method? Run method. So that whenever you execute a thread, your thread is executed by calling which method? Run method. Run method, and here you include an operation of a thread. Operation of which one here? Thread. operation of a thread, you are writing inside which method? Run method. So what will happen? Just here, see between the previous example and this example. Same example I'm writing it, but this time I'm not creating a thread object and defining target, but rather than I'm directly creating a thread by inheriting which class? Thread class. So import what is it? Threading module, and there is a class, and what is it? Event thread. What is the name of this thread here? Event thread. Event thread inherit. Event thread inherit which class here? Thread class. Threading dot thread. So event thread inherit which class here? Thread class. Miss event thread is a, what is the meaning of this? Event thread is a thread. Event thread is a thread. Event thread is a thread. Inheritance is a relation or not? Yes. Event thread is a type of thread because is it inheriting all the characteristics of what? Thread. To inherit, is it to call the constructor or not? Yes. I'm writing one constructor here. What is the name of the constructor? Init. And this constructor calls the constructor of which class? Super class. What is the super class for this thread? So when you call the constructor of super class, is it all the properties of thread class is inherited in which class? Even thread class. Then where you write the operation of a thread, this even thread should perform some operation or not? Yes. Even thread should perform which operation? Generating which numbers? Even numbers. Then where you are writing that? Inside one method. What is that instance method? Run. So whenever you execute a thread, your Python virtual machine calls which method? Run method. So within run method, you write the logic for generating which numbers? Even numbers. So for n in, for n range of 1 comma, what is that? 21. If n mod 2 double equal to 0, you're trying to print which number it is? Even number. You're printing which number it is? Even number, right? So this is called as which thread here? Even thread. So the job of even thread is generating which numbers? Even numbers. The job of even thread is generating which numbers? Even numbers you are generating it. Even numbers you are generating it. And there is one more class. What is it? Another class here? Odd thread. So odd thread is inheriting which class again? Thread class. Odd thread is also inheriting which class? Thread class. So even thread inherit thread. Odd thread also inherit what? Thread. So it should inherit the properties of a thread. For that, I call the constructor method of which class? Super class. But how you are calling it? By saying super dot, you are calling which method? Init method. So this will call the init method of which class? Super class, right? This will call the init method of super class, and the operation of a thread is written in which method? Run method. So run method. Within run method, I'm saying for n in range of 1 comma 21, and if n mod 2, if n mod 2 is not equal to what? 0, then you are printing this is which number? Even or odd? Odd number. I just say odd and print which value? N value. So I created how many threads now? 2 threads. But are you created threads by inheriting or not? Yes. Not using callable objects. See the previous example and this example. So this is a previous example where we develop functions and we created thread objects and define what? Target. But here we develop directly which one? Thread. We develop directly which one? Thread. Directly we develop a thread inheriting which class? thread class. So after that, I'm creating two threads here. One is I create an object of which class? I create an object of which class? Event thread. I create an object of which class? Order thread. Created object of event thread and created object of which class? Order thread. Please just try to understand. Very simple it is. Okay, I created object of event thread. I created object of which one? Order thread. After that, I invoke which methods here? Start method. T1 dot start and T2 dot which one? Start. So will it this start executing threads or not? Yes. By calling which method here? Run method. Let's go to this here. Now you can see first it is scheduled which one? Event thread. After generating how many numbers here? Two numbers. Switched to which thread? Order thread. Then switched to which thread? Event thread. Then switched to which thread? Order thread. Is it all these are executed how? Simultaneously or concurrently? Simultaneously or what? Concurrently. Right? Yes. Now, where exactly? See, we'll see one application. What will happen generally in application development? Okay. What will happen in application development? Okay. Just to see here. But try to understand how to create a thread first. Okay. So suppose what will happen in application development is, for example, okay, assume that there is one server is there. What will happen in application development is, for example, there is one server is there. What is the name? Server is nothing but a program or not? Yes, server is one program. And server is the program which provides some services. Each service can be called as one operation or not? Yes. Each service is called as which one? One operation. Assume that. So there is one server is there. What is that server? Alpha server is there. What is the name of the server? Alpha server is one program. Now this server, it will try to provide some services. Alpha server provide is, it will provide a service like generating alphabets. Alpha server provides service for generating which one? Alphabets. Alpha server is used for generating which one? Alphabets. Now assume that there will be multiple clients. So there will be multiple clients who send a request. Okay, now there is a multiple clients who send a request to which one? Alpha server. So there is a multiple clients out there. So these are multiple clients who send a request to which one? Alpha server. So there is a client one is there. Is a client one and there is a client two and there is what here? Client three. So all these clients will send a request to which one? Alpha server. Alpha server, and this alpha server is having one service. It is having one service. What is that service is generating which one? Alphabets. What is the service it having here? Alphabets. It will generate which one? Alphabets. What is alphabets here? One service or is it one function? Alphabets is one service or it is one function. For example, assume that client one is send a request to the server for generating which one? Alphabets. Then what alpha server will do is, it will generate alphabets for which one? Client 1. Okay, then client 2 send a request to the alpha server, and client 3 also send a request to what? Alpha server. But what alpha server should do is, it should provide the output of alphabets to how many clients? 3 clients. Assume that if alpha server is single tasking, what? Single tasking, then for how many clients it will generate alphabets at a time? Only 1. Suppose first it is generating alphabets for what? Client 1. But until client 1 alphabets generation is not completed, is it able to generate for client 2? No. Is it able to generate for client 3? No. It means client 2 and client 3 should wait. Client 2 and client 3 should wait until execution of which one? Client 1. But I don't want that. Don't want one client should wait for what? Another client. So first it should generate some alphabets for client 1, then switch to what? Client 2, then switch to what? Client 1, and switch to what? Client 3, then switch to what? Client 2. We should do it how? Simultaneously. Then what server will do? For every client it will create one. Whenever client send a request for that client, it will create what? Thread. For every client it will create a thread. And this thread will call which function? This call which function here? Alphabet function. It means is threads are executed one by one or simultaneously? Simultaneously. Now, is it all these clients request is processed one by one or simultaneously? Yes, I can go for which application? Multi-threaded online shopping, online banking. So there will be multiple clients will send a request to the server or not? Yes. So until one operation is not completed, will it do that? No. All these requests will be processed how? Simultaneously or what? Concurrently. In that case, most of the web servers are what? Multi-threaded. Okay. Yes. Just to see this application. But in the place of server, we'll just write a program. That's it. But whenever you create a thread is created with some properties. Every thread is having some properties. Okay, now. So the thread object is having the following properties. Following properties are what is that? Attributes. You can call it as attributes, or the same thing you can call it as what? Instance variables. The same thing you can call it as which variables? Instance variables. So thread object is having the following properties, or it is having which one? Attributes. Having the following properties are what is that? Attributes. Properties are attributes. Okay. So every thread is having a property called which one? ID. And thread is having which one? Name. Whenever you create a thread, your thread is created with two properties. One is ID and one more is what? Name. But ID is unique, but name cannot be unique, right? It can be duplicated also. Okay, you can give more than one thread same name, but you cannot modify the ID, but you can modify which one? Name. So your Python virtual machine identify the thread with what? ID. Python virtual machine identify the thread with what? ID. But you can identify the thread with what? Name. Okay. So ID is unique. ID is what here? Unique. And ID is readable. ID is what here? readable. We cannot modify. We cannot modify or update. We cannot modify or update which one? ID. So PVM identifies, okay, PVM identify, okay, PVM identify each thread with what here? ID. So every thread is also given what here? Name. And this name can be what here? Modified. This name can be modified or what? Updated. This name can be modified or what? Updated. By default constructor. By default constructor of thread generate unique thread names. Okay, unique thread names, like it will start with thread 0. Okay, thread 1, like this. It will generate by default with some names. Start with what? Thread 0, thread 1, thread 2, like that. Okay, but if you want to change the name, you can just use the attribute called which one? Name. And this attribute name is a public. This attribute name is also what here? Public. And I think you know it. Every Python program is executed by whom? PVM. PVM, right? Every Python program is executed by whom? PVM. Is it PVM is one program or not? Yes. PVM is one program or PVM is one process. PVM is one program or PVM is one process. And within PVM, your program is executed as one thread. So every Python program is by default executed as one thread inside what? PVM. Every Python program is executed as one thread inside what? PVM. So who will, by default, PVM create one thread. What is that thread? Is main thread. That main thread invokes which statement? Executable statements. Whatever executable statements you are writing inside your program, all those executable statements are called by which thread? Main thread. But who create this main thread? PVM. So every program in Python is executed as one thread. Apart from that main thread, you also create your own thread. So it means in the previous example, if you see this example, how many threads are there in this example? You created how many threads? You created how many threads here? 2 threads. One is a thread 1 and one more is what? Thread 2. But there is one more thread also there or not? Yes. What is that thread? Main thread. But who is creating a main thread? PVM. So total how many threads are there? 3 threads are there. One is a main thread and one more is a T1 and one more is what? T2. So total number of threads are how many here? 3 threads. And all these threads get, it means main thread create a thread 1 as well as what? Thread 2. Main thread creates a even thread and what? Odd thread. Now you have to understand this, right? So every Python program, now this is one more thing here. So every Python program is executed as a thread inside which one? PVM process. Every Python program is executed as a thread within PVM process. So default thread created by what is that? PVM is called which thread here? Main thread. What is the name of that thread? Main thread. And this main thread calls or invoke which statements? Executable statement. All executable statements are invoked by which thread? Main thread. So this main thread calls or invokes all executable statement. You can see in documentation, if you have, you can just see that. So main threads here, this is main thread. So your main thread is there, return the main thread object in normal conditions. Main thread. main. Okay. So you can also find out which thread is currently in execution. Yeah, we'll just see here. Just see this method here. Just see, and you want to know which thread is currently in execution. You can say threading dot. What is the name of this method? Current thread. Threading dot. Which method is there? Current thread is there. Threading dot current thread. So return the current thread object. Return the current thread object. So return the current thread object corresponding to the caller's thread of control. If the caller's thread of control was not created through a threading module, a dummy thread object with a limited functionality is returned. Okay. Yes. So current thread will return a thread object corresponding to the caller thread control, right? Who's the caller here? PVM. Now just see here. For example, now I'm just writing here import which module? Threading module. And I'm writing T1 equal to threading dot. What is this here? Threading dot thread dot. What is the name of this method? Current, sorry, directly function, right? Threading dot. What is the name of this function? Current thread. Okay, now who is calling this particular statement? This statement is executable statement, right? Who calls this executable statement? PVM. But PVM is one program or not? Yes. Within that program, your program is executed as what? Thread. So PVM will create one thread. Which thread it will create? Main thread. And that main thread reference is written to T1 or not? Yes. I'll try to print. Print T1 dot name. So every thread is having an attribute called name or not? Yes. Every thread is having an attribute called which one? Name. Every thread is having an attribute called name, right? Okay. So it will return name of this thread. What is the name of this thread? Main thread. Are you created any thread? No, you have not created any thread. This thread is created. Main thread is created by which one? PVM, that is Python virtual machine. This main thread is created by Python virtual machine. So you have to understand this. One more thing related with the Python. So Python is a multi-threaded. Actually, Python itself is what? Multi-threaded, because every program in Python is executed as one thread inside which one? PVM, that is Python virtual machine. Same like Java. Same like which one? Java only. Java. Every Java program is executed by JVM. And every Java program is executed by JVM as one thread. So what is the thread? There it is created main only. So here main, and there is also what here? Main. So both architecture is what here? Same. But syntax is a difference from Java to which one? Python. Okay, now, right. So how can I get the reference of the current thread which is currently running? How can I get the reference of the current thread which is currently running? By using one function called which one? Current thread. How can I get the reference of the current thread which is currently running? By using the function called which one? Current thread. So that will return the reference of which object? Current thread object. Okay, now, right. So we'll see more on this, like how to work with this multi-threading, but tomorrow we'll see, right? So this application I'll tell you. This application even we'll see tomorrow, right? Today we'll stop it here and tomorrow we'll continue this, right? Thank you. Right.